Hi class, today we're going to talk about the Bohr model of the atom. So last time we spoke about uh, the fact that different elements have different emission spectra whereas you heat up the element, it'll give off very specific frequencies of light. And we also said that each element has its own absorption spectra, whereas if you shine light at it, light that contains all the different colors, it'll only absorb very specific colors of light. And so Bohr came up with a model to explain that. And Bohr's model has electrons orbiting the nucleus in orbits that have a set size and energy. So what he's saying is an electron can orbit the nucleus, but it doesn't just have one possible orbital. It can orbit at one level, but it can also orbit at another level. And this would be a higher energy level, or it could orbit at another level. And for hydrogen, there were actually 6 possible energy levels. So the electron doesn't necessarily have to occupy one single orbital, it could occupy 6 different possible orbitals, and each of those orbitals has a different energy level. The lowest energy level is found in the smallest orbit, so we would call this one level. That would be the lowest energy level. And if the atom absorbs energy, the electron could be stimulated to a higher energy level, let's say energy level 2 or energy level 3, and so forth. So, and how does that happen? An electron can become excited if it is given extra energy, such as if it absorbs a photon or a packet of light, or perhaps it collides with a nearby atom or particle. So these electrons can become what we call excited. They can transition into a higher energy level. And as it transitions from a low energy level to a higher energy level, it absorbs energy. So that's why if we shine light at it, it will absorb certain frequencies of energy. What's happening when it absorbs energy is that the electron is transitioning from a low energy level up to a higher energy level. And vice versa, when the electron transitions from a higher energy level back down to a lower energy level, it will emit light, or it will emit photons of a very specific energy. So that is the Bohr model. Let's try and show a little graphic here to demonstrate that to you. So here what we see is a representation of the Bohr model. There we go. And what we have is some photons are coming in, and you can see this little blue thing here is the electron. And you can see the electron goes from this low energy level and it jumps up to the highest energy level, and it moves down back into the lower energy levels. So you can see the electron is sort of jumping around in the atom, but it only jumps to these very specific energy levels. All right, let's slow this down a little bit and look at what happens in a little bit more slow motion here. So you can see the electron right now is at its lowest possible energy level. And boom, right there, it just jumped from here all the way up to here. Here's the electron right now. So the electron absorbed energy, and the electron jumped up into an excited state. It's now in the energy level 6 state. So it absorbed energy and it transitioned all the way from 1 all the way up here. You can see this little arrow pointing up here. And now that electron is in the energy level 6 state. Now, it turns out that it can only absorb very specific frequencies. If this photon of energy that came in had a little bit less energy, and it would have been the perfect amount of energy to transition it up to, say, somewhere between energy level 5 and energy level 6, it wouldn't absorb that energy because it wouldn't be the right amount of energy to get it to transition perfectly to one of the energy levels for hydrogen. So if the photon doesn't have just the right amount of energy, that photon won't be absorbed and it won't cause a transition. That's why only very specific frequencies of light are absorbed when photons are incident or coming in on an atom. Okay? But now let's look at what happens when this electron moves. So here it's sitting up here at energy level 6, and boom, it just dropped all the way down to energy level 2. Well, what happens when it makes that transition is it gives off a photon of energy. So when it makes a transition from a high energy level down to a low energy level, it gives off a photon of energy. We can see that in the diagram over here, as when it transitioned from energy level 6 to energy level 2, it gave off a photon of a very specific amount of energy. The energy of that photon is exactly equal to the difference in the energy of level 6 and level 2. So that photon is going to have a very specific amount of energy. It's going to have the amount of energy that is the difference between two energy levels, which is why we only get very specific photons coming out. What this is tracking down here is all the photons that come out as electrons transition from a high energy state down to a low energy state. So they don't necessarily have to transition always from level 6 to level 5 and then level 4 and then level 3. They can go 6 all the way down to 2 and then later on transition down to level 1, as we're seeing here, 6 down to 2 down to 1. They could go 6 to 3 and then 3 to 1. So as long as they will eventually transition back down to energy level 1, they don't have to go directly though. They can go in jumps. But they have to jump on these very specific levels though. Okay? So, and then let's see if we can watch that. Boom. You can see it just jumped from level 2 down to level 1, level 2 down to level 1, and it gave off a photon of a very specific amount of energy. Okay? And let's speed this up a little bit now. And boom. So we're going to send in a whole bunch of photons now. And what you'll see here is as the excited electron drops down from level 6 down to all these different levels, sometimes it makes short transitions, sometimes it makes long transitions, but it can only jump between these very set energy levels. And so you get very specific energy photons coming out, which is why we get very specific colors coming out in the emission spectra of hydrogen. Okay, and as this thing runs and runs and runs, you'll see more and more photons coming out, but they are always very specific color photons because you're only going to get photons that have the exact amount of energy as exists between two different energy levels. So you might jump from energy level 5 to energy level 1, you might jump from energy level 5 to energy level 2, but it has to jump between energy levels, and so you can only get photons that have the exact amount of energy that would be equivalent to the difference between two energy levels. So in this case, it jumped from energy level 4 down to energy level 2, and we got a very specific color of light coming out. Okay, so just to summarize, the previous model was the Rutherford model of the atom, where we had a nucleus with electrons that just orbit around the nucleus. With the Bohr model, we still have a nucleus, and we still have electrons that orbit around the nucleus, but the electrons can exist not just in one particular orbital, they can exist in multiple orbitals, and each of those orbitals has a different energy level. Okay, so electrons orbit the nucleus in orbits that have a set size and energy. The energy of each orbit is related to the size of the orbit. The lowest energy is down here at the smallest orbit. And radiation is absorbed or emitted when an electron moves from one orbit to another. So if an electron moves from a lower orbital level to a higher orbital level, that happens because the electron absorbs energy. And when an electron moves from a higher energy level down to a lower energy level, it emits a photon. It gives off the difference in energy between those two levels in the form of a photon. So light energy radiation comes off of the atom. And this model of the atom explained what needed to be explained, which is why elements, when you heat them up, give off very specific colors of light, and why, when you shine light at an element in its gaseous form, does it absorb very specific colors of light. And so the Bohr model helped explain absorption and emission spectra, and is the next evolution in the model of the atom. Okay, so thanks, and after you finish watching this, just go ahead and answer the questions on the Google form. Thank you.